So, hello everyone. I am Abhilash Kumar, and I and my group mates, who are Aditya, Mallik, Himanshu Srivastava, and Rahul Kumar, are going to present our a paper presentation on the topic of construction and implementation of reversible logic gates. So, this course is actually guided by Professor Hitesh Lohra sir. Continuing to the contents, we can see the contents here, and straight moving forward towards the introduction. So, just to tell about why this topic we chose. So, reversible logic gates is something which we found new, which is not included in our syllabus. So, we thought of we thought of to prepare research review paper on this topic. So, as we know that in present day technology, the energy loss is a vital thought, that we actually want our technological developments to be energy efficient. So in this aspect, traditional logic lacks something in some areas. So to overcome this, we actually use our reversible logic gates. And if in short I can comment on what are reversible logic gates. So in reversible logic gates, the number of inputs is equal to the number of outputs, and there is an input which actually drives the input and output of the logic gates. Some theoretical concept about the logic gates, reversible logic gates, is that the energy dissipated is in the order of kT ln 2 joules. That is loss per bit of data. And now coming towards the some basic definitions associated with the reversible logic. So a reversible function, multiple output boolean function of n boolean variables. Then we have reversible logic gate, which actually I told that number of inputs is equals to number of outputs. Then garbage outputs, gate level, hardware complexity. Specifically talking about this, hardware complexity refers to all the full range of operation and in a circuit. This means the total number of AND, OR, and XOR operations in a circuit. So this was a brief introduction about the reversible logic gates. We will now move towards the principle behind these logic gates.
So hello, I am Aditya, and we will now discuss about the principle behind reversible logic gates. So in the irreversible logic gates, the problems are like missing the information and the heat dissipation. The loss of information is associated with the laws of physics, which all we all know, that K into T into L into energy. So we need to reduce this information loss from the energy and also the heat dissipation. So here the first principle is that in logical reversible, any device can be reversed so that input and output can be reversed separately from one another. So in reversible gates, for each input there is a output, and for each output there is a input. So the inputs and outputs can be reversed separately. So this is the first principle, and the second principle is that the device can actually run backward physically also. Then they can be said to be physically backward. So these two are the main principles which are applied to make a reversible logic gate. So next, Himanshu will continue.
So, if we're talking about reversible gates, they are different types. For the first is the Feynman gates, second is Fredkin gates, and the third is Toffling and the Paris gate. Talking about the fine gates, in this the the fine gates has the two input and the two output. We call that it is also known as the control not gate. So if talking about the Fredkin gates, so Fredkin's gates is used to implement for the multiplexer, and for the Toffling gates, Toffling gates is used to designing the multipliers. And talking about the phase gates we use for just to used to realize the various Boolean function such as AND gate and the OR gates. And after it, we just construct full adder using the reversible gates. So in the reversible gates, we can use different gates like we talking about Feynman's, Fred King, toppling on the Paris. So we go through with uh, Ferris gates. So this is the implementation that simple block diagram. In this we use two Ferris gates. Full adder is the adder which add the three input and produce two output. We can see that G2 and the sum and the carry. And the first two input are the here A and B, and other is the input is the carry. So talking about the output of the design of the C output, are the normal output is designed as as a sum we get as a output. This we implemented this. The further thing continue with the Rahul.
So, hello everyone. I am Rahul Kumar. So, as my friend have discussed the introduction principle and the diagram. So, from all the theories discussed by my friends, the conclusion that we come on is like the reversible hardware computation leads in energy dissipation due to information loss. As Abhilash have discussed about the necessity of the energy conservation. Following that, we have the conclusion that we come on is that reversible logic has received considerable attention within the recent years, and this is quite true about this is very true. Now, the reversible logic ability to scale back the power dissipation, that is the main demand in low power VLSI design, and based on that, it has a wide application in low power CMOS and optical information processing, quantum computation, and nanotechnology. And beside that, we do have many applications based on this particular research paper that we tried to publish. So, yeah, this was it about this paper, and thank you so much.